What is GAM's future in golf course measuring? 6 golf associations currently measure courses using the GNSS method. What is this measuring system? It's a system that collects ground data in the field. GNSS is a satellite system that transmits position data to ground receivers. What's required to gather GAM's measurement data? The field person measuring needs a receiver that reads satellite signals. The measurer carries a device with software that collects the data from the receiver via Bluetooth. It's called a collector. Once field data retrieval is completed, it is sent to GAM's office for post-processing to populate the measure data sheet and GAM's Form 1s. GAM has basically 2 receiver options to perform these tasks. One of GAM's choices is the Trimble R1 receiver. This device can be clipped to a belt, worn as a hat patch antenna, or mounted on a surveyor's pole. Each means of transportation has its own advantages and disadvantages. The Geode GNS2 receiver has primarily 2 options for transport. Both carrying options allow the antenna to be above one's head and not interfere with satellite or base station reception. The pole option frees one hand for data input, while the backpack option allows both hands to enter data into a tablet or phone. Now that we've looked at our 2 receiver choices, let's compare some of their specifications and features. The Trimble device without the upgraded accuracy package has a horizontal accuracy of 40 inches and a vertical of 10 feet. The GNS2 device's base package has a horizontal accuracy of 12 inches and a vertical of 24 inches. The R1 requires additional software to obtain better accuracy. We will see what's required later in this presentation. The GNS2 has built-in software already. These base stations facilitate further post-processing accuracy from the data obtained. They are free services provided to the public. The more channels the receiver has, the quicker it will fix onto satellites and the nearest base stations. The GNS2 makes an instantaneous lock on the satellites. The R1 can take up to 45 seconds to make this connection. The Geode can be immersed in water up to almost 5 feet for 30 minutes. The R1 can only endure low jetting water from a hose. The GNS2 is $500 less. We've compared the receivers, now let's compare the software features. The Trimble R1 software is customized to GAP's criteria. It can only be used with an R1 receiver. The Trimble R1 software is utilized by only 6 golf associations. This system only works with GAP's Trimble R1 software. It allows for any number of holes. It allows up to 7 tee marker placements. GAP collects tee locations, pivot points, the path between those points, and the greens front and back. GAP's software calculates yardages, tee to green center. GAP's software does not provide or facilitate green widths, bunker depths, or approach shot elevations, or partitioning of multiple tee marker locations on a pad by percentage use. GAP stated they have no desire to customize to GAM's Form 1. What does the Geode GNS2 offer, and how is it different? Geode software serves over 10,000 clients in the GNSS marketplace. GAM can include all required masthead information. It allows for any number of holes. If a course changes pads or colors, GAM can adjust. Should the USGA totally revise their measuring criteria, this software is versatile and is not confined to another system's predefined programming. Geode software calculates any combination or string of point distances and has the capacity to accurately measure bunker depths and elevation changes. Geode software allows GAM to pinpoint and historically document any desired location throughout the golf course. For example, an existing in-ground permanent GAM marker, whatever GAM deems important and wants to locate or document for the future. The GNS2 software is versatile, flexible, and adaptable to change. It collects as much or as little data as GAM deems necessary at the time. Should the USGA change measuring criteria, this software can be revised to facilitate those changes. Remember the fixed SBAS, Coors, MDOT base stations in slide number 5? The word fixed here is key. They help establish the triangulation distances between the base stations, satellites, and field collector unit. This relationship is what further defines the final horizontal and vertical distance accuracy during the post-processing phase back in GAM's office. This slide is taken from the 2020 USGA Course Rating System Manual for Approved Methods of Measuring Golf Courses. Please note the verbiage highlighted in yellow for the use of global positioning systems. Quote, "This method can be used to measure golf courses if the global positioning system, GPS, is accurate to within 6 inches for up to 250 yards. The Geode system meets this requirement. The Trimble R1 system does not." This slide depicts 80 raw data points taken by the collector's software in the field. The orange square represents the Geode's 4.4-inch dimensions in perspective. 74 of these points are within a 2-foot diameter circle. Pretty good accuracy. This slide represents Geode's accuracy for the previous slide's 80 field-tested data points when post-processed through the SBAS Coors stations. The orange square represents the Geode's 4.4-inch dimensions in perspective. All 80 of these points conform to the USGA's accuracy of less than 6 inches as specified in the USGA Course Rating System in Section 6, Measuring Golf Courses. Better accuracy than the R1's 40-inch diameter. Of Geode's 80 elevation raw data points gathered in the field, only 50 points were within the 12-inch vertical mean. Slide number 12 stated the Geode's pre-processed accuracy yielded a 24-inch variance in the vertical. Let's see what happens when Geode's post-processing accuracy is performed. This is the accuracy obtained when the 80 elevation field data points are post-processed. The corrected elevations via the SBAS Coors stations vary plus or minus 4 inches, or 8 inches from the mean. Even better accuracy. The preceding 4 slides were conducted in the field around their parking lot, and the manufacturer states these represent ideal conditions. Option 1 reflects the least expensive cost estimate. Keep in mind the R1's $1,550 a year license fees. Option 2 depicts the upgrades for both the Geode and R1. Both ESRI software and Trimble were contacted to verify the upgrade software requirement to match Geode's accuracy. All R1 software licenses are on a yearly basis. The Geode has a 2-year warranty with lifetime support. After 2 years, it's a flat labor charge of $125 plus parts. When GAM purchases the Geode receiver and software, the accuracy upgrade is included in the base price. There are no yearly fees or licenses required. For GAM to continue using GAP's software and achieve Trimble's accuracy measurements of 13 inches horizontal and 40 inches vertical, GAM must renew the yearly $4,550 licenses and fees. Additionally, GAM's commitment to the GAP Trimble system should consider this system does not meet the USGA's measuring criteria for a horizontal accuracy of 6 inches at 250 yards. Ground penetrating radar systems utilizes over 200 geodes daily in the field throughout the United States. As a business decision, GPRS stated their company ditched their more expensive Trimble Geo 7X series and 6000 series units in favor of the Geode system. The Geode system, coupled with the EZTag and EZSurv software, is more intuitive and versatile than their discontinued Trimble systems. Additionally, in over 2 years of abuse by 300 field personnel, they just recently sent a Geode unit back to the manufacturer to replace a USB connection. They have had no other issues to date with the Geode system. This slide is a schematic depicting the steps for collecting the geospatial field data, creating a data dictionary, loading Google Earth or other maps, how this data is collected, and how it is post-processed back at GAM's office. Here's a backpack sample of what the field person can use to carry the receiver, tablet, and other paraphernalia while collecting data. In place of using a backpack, another option is mounting the receiver to a surveyor's pole.